Hi, everybody. Welcome back. So the last thing that we talked about was positive positional subsetting, negative positional subsetting for non-atomic data, both rectangular non-atomic data, i.e. tibbles, and non-rectangular non-atomic data, i.e. lists. And we mentioned that we cannot use negative positional subsetting with names, but we will learn how to do that in a future lesson. But we would be using positive positional subsetting by name, or we could do positive or negative positional subsetting with the integers, with the indices, the positions of the information. Now, relational subsetting, this is incredibly powerful. It builds on the idea of Boolean or logical subsetting. So if you need to refresh that, go back to this lesson on atomic vectors and read about how to do logical subsetting. Okay. But the idea is still the same. The idea is you're going to be creating a vector of trues and falses that match to either the columns or the rows of your data set. Okay. And that's if you've got rectangular data. If you've just got a list, then it would just be a vector of trues and falses that match to the positions of the list. Okay. So, um, so right here, extract a subset of the tibble using your preferred subsetting rules. So relational subsetting, the whole purpose of this would be like, I want to find all of the rows of my data with cancer cases, or I want to find all of the rows of my data that are males between the ages of 18 and 35. Well, in order for me to do that, in order for me to say, so I've got like, tens of thousands of records in my hospital system, if not hundreds of thousands of records in my hospital system, in order for me to find the records for all of the males between 18 and 35 years old, I first need to go find the measurement that says what their sex assigned at birth is. So step one, I need to go here and extract the column from this data set that says, were they male, assigned male at birth? And the other thing that I would need is I would need to extract the column of their ages. All right. And then I'm going to use logical comparison operators or Boolean operators to say, okay, are they the sex assigned at birth? Is this male? And then it's going to give me a whole bunch of vectors of trues and falses for everybody, whether or not they were assigned male at birth. And then I'm going to have another column where I say, are they between the ages of 18 and 35? Now, this other column that includes the people that were assigned female at birth. Okay. It's not going to say, I'm not going to just perform this logic on only the people that were assigned male at birth, but I'm performing the same logic on everyone to say who is between the ages of 18 and 35. And so I would do one logical comparison where I say, is their age greater than or equal to 18? And then a whole bunch of trues and falses. And then another logical comparison where I say, is their age less than or equal to 35? And another logical comparison. So I've actually got three logical comparisons. So I say, were they assigned male at birth? Are they at least 18 years old? Are they less than or equal to 35 years old? And then I'm going to basically what I'm going to do is I'm going to use a whole bunch of and statements to find the people who are male and greater than 18 and less than or equal to 35, or greater than or equal to 18, less than or equal to 35. So I'm going to have a whole bunch of trues and falses in each one of these three columns, but my resulting fourth column is only going to be the subjects that are male, are 18 years of age or older, and are 35 years of age or younger. Okay. This vector, this is going to be a single logical atomic vector. Okay. And if there's 20,000 records in the data set, there's going to be 20,000 trues and falses. Then the final step is I subset the full data using this logical atomic vector. I say, give me all of the rows of this data set where this new logical vector is equal to true. So that's the outline of relational subsetting. But you can imagine relational subsetting is very powerful. If you have ever heard of a language called SQL or SQL, SQL is a database language, and relational subsetting within that database language, it's been like the bread and butter of data science since the 70s. How you would connect data from multiple different tables, and you would use these logical subsets. You would say where this is true, and this is true, and this is true, and this is false, whatever it is. And then that allows you to drill down and get subsets of your data that are appropriate for your analysis, whatever it is. Okay, so Boolean subsetting, this is an example of this. All right, so if I want to, let's see, I want to subset the heroes data frame. So I've got 5 rows and 8 columns. So I want to create a logical vector that I want to keep. If I want to keep the last 2 rows, then I would need to create a logical vector that is false for the first 3 rows and true for the last 2 rows. And you've had examples and exercises like this where you combine the C function with the repeat function to get relatively quick and flexible, honestly powerful vectors of logical information. So and then this one right here, if we were looking at just getting, so if we wanted the last 2 rows of the data set, and we want the last 4 columns of the data set, then we would say, okay, here's the heroes data set. I want the last 2 rows. So notice I've got repeating false 3 times. So don't give me row 1. Don't give me row 2. Don't give me row 3. Yes, give me row 4. Yes, give me row 5. And then the columns, don't give me column 1, don't give me column 2, don't give me column 3, don't give me column 4. Yes, give me column 5. Yes, give me column 6. Yes, give me column 7. Yes, give me column 8. Okay. And so that gives me this data set right here. Okay. And I notice here that this kind of got a little bit unwieldy. So oftentimes this gets broken up into a couple of different steps. So the first one is you create an object that just has the rows you want to keep. Then you create another object that has the columns you want to keep. And then this subsetting, it gets a lot cleaner. It's a lot easier to read than this one. Honestly, this is like, if I had to go back and troubleshoot this later, it's not terrible, but I could see this getting much, much worse. This structure of code writing is a lot easier to kind of wrap your head around and keep up to date and maintain as your code starts to be used by other people. Okay, so now this was an example. Let's get into how we would work with this in a list, okay? If you remember, tibbles are lists. So therefore, the same way that I subset lists, I can also subset tibbles. So if you remember, lists is sort of like this collection, this strand of elements. You could just say, give me this position and this position and this position, or the elements in this, the column in this position, the column in this position, the column in this position, and not worry about subsetting the rows. This will work as well. But notice I can't subset the rows this way. Notice what is missing. There's no comma in here other than what's inside of the repeat function. So list subsetting says, I don't bother with rows and columns. Don't say row, comma, column inside of this single square bracket. So anytime you just give a single logical vector and say subset by the single logical vector, R assumes that you are talking about subsetting the columns of that tibble. Okay, so this is very important. If you don't specify which one it is, because you didn't specify a comma or you didn't put a comma there, then R will assume that you are asking for the columns of this tibble. Okay. And so here's an exercise for you. I'll let you work on this on your own time. Okay. Now, character set membership, we've given this example before about if we wanted to find whether or not Florida spelled with a capital F is in one of the many variant spellings of Florida, we can use one of the infix operators. This is the set membership infix operator, known as just percent in percent. And then that will tell us whether or not this is true or false. So yes, Florida with the capital F, everything else lowercase, is in this set. It's actually right here. Is Georgia over here? No, Georgia is not in this set. So that would be false. So this is what you could use if you wanted to, let's say we've got we've got our hospital data set with, 20, 30, 50,000 records. And you say, okay, I want to find everyone who lives in Palm Beach County, and they drove all the way down to Miami for whatever reason. So find me all of the people that live in the zip codes in Palm Beach County. Or you say, okay, well, I want to find anybody that's not in Miami-Dade, Broward, or Palm Beach County. So who's outside of South Florida? Then you could reverse this by putting a not, like the exclamation point in front of all of this. So if you want to do partial matching, so this is pretty advanced. In fact, there's an entire lesson dedicated to this. Let's see, it's going to be the wrangling character strings with the string R package or stringer package. So I'm not going to spend a whole bunch of time talking about this right now, but just be aware that you can do partial matching if you use the string detect function. And it's vectorized. So it's going to tell me, it's not just going to return a single false or true, but it's going to give me this vector of trues and falses. Okay. Um, all right. And then now for like the good stuff. And actually, you know what? I think this would be a good place to pause and pick back up with the next video before we get into like the relational subsetting for tibbles, because this would be a good example here. So I will see you all next time.